Simple squamous is the first official tissue that we're going to look at for epithelial. As its name suggests, because it has two names, the cells are egg-shaped, squamous, and there is only one layer of these cells. Simple, right? So this takes a different approach to looking at your fried egg. I'm no longer looking at your fried egg from top down. I am now looking at your fried egg from the side, as if you cut your sandwich and looked at it from the side. This picture on the left that I circle is how you would see your squamous cell cut and looked at from the side. In the lungs, these squamous cells line little open cavities called alveoli. And it's these alveoli or open spaces that all form the lumina that the simple squamous cells line. On a microscopic slide, this just looks like a bunch of pink wavy lines. But each lumen is an open space with cells that are not stacked, but just ever so slightly overlapped at the edges, just ever so slightly. This tissue, simple squamous, is also found lining the open chambers of your heart and lining all of your blood vessels. They're very flat cells and they give very little resistance to blood flow. Oh, and I apologize. I have a picture of grapes here because if you think of the shape of hollowed out grapes, that is kind of how your lungs are. There are a whole bunch of spherical alveoli that are hollowed out and have open spaces. We can determine the look of this tissue before we even see it. We know from the name that this tissue is going to have layers. It's stratified. And we also know from the name that it's going to have egg-shaped cells, squamous. We are also prepared to see these egg-shaped cells from the top down or looking at them from the side. We will be viewing them in a cut that shows them from the side. These two pictures on the left are linings of the vagina, which is stratified squamous, and these two pictures are created with two different stains. The purple stain in the middle, it's a more common stain that we'll be seeing that dyes epithelial tissue that characteristic purple. But down here on the left, the epithelial tissue is dyed red. And we'll see this stain occasionally. It's actually a combination of three stains, and it's called Mason's trichrome. You can see all the squamous cells in both pictures with many, many, many layers stacked up on top of each other. Some of the cells still have their nuclei, some of the cells don't. This picture on the right is a little bit more difficult. It's a picture of the epidermis of skin, and this was bad of me. I have not included the lumen in this picture, which would actually be up here. This would be the lumen up here. And you can see this pink stained picture down at the bottom. That's actually the connective tissue that the epithelial tissue is attached to. All right, so this top layer here is a layer of about 30 to 50 different layers of dead, flattened cells. This layer down here, which has some valleys and hills, this is a layer of about 10 layers thick and is a layer of live, plump, keratin-filled cells. So sometimes the same epithelial cell can look different depending on its stage of life. And this reminds you that epithelial tissue does really fast mitosis. And so you might see cells in different stages of life and death. And those stages can determine the cell's ability to take up stain.